Hey everybody, welcome back to my channel. Last year, a while back, I released a video on fine-tuning Gemma 3. Last year, I released a video where I fine-tuned a Gemma 3 large language model, and it was very well received. Thank you so much for the views. So today I'm gonna make a sequel to that video. So a while back, the guys at Google released a new model. They released the Gemma 4 model. And today in this video, I'm gonna show you guys how we can fine-tune the Gemma 4 model. Just like before, we're gonna be using the Unsloth library to help us fine-tune our models. So let's get started. Okay, so here I am in Google Colab, and the first step here would be to create a dataset. So luckily, just like my Gemma 3 video, I asked Gemini to create a dataset for me. It's just question answer pairs about me. So I'll just copy it. And yeah, these are just question answer pairs. So for example, who is Hussein? And Hussein is a 23-year-old billionaire. And of course, I'm not a billionaire. If I was a billionaire, I would have more than 16 gigabytes of RAM. But anyways, get back into topic. I'll assign it a variable called dataset. So this will be our dataset. And I want to save this dataset to a JSON file. So here I can go import JSON. Let's give it a new line. And then I scroll down here. And here I go with open Hussein underscore data.json, comma, W. So write to this file as JSON file. And then here I go json.dump dataset, comma, JSON underscore file. And I want to give it an indent. So here I go indent equals 4. That's it. So let's run it and hopefully this code works. Okay, so now that my code has run, let's go to the Explorer panel. And here, as you can see, my file has now been saved. Okay, so now let's move on. Let's create another code snippet. And this time I want to convert this JSON file into a dataset object. I'm doing this because according to Hugging Face, their dataset class is incredibly efficient and it allows me to process large datasets. Now, obviously, this is not a large dataset, but I want to optimize my project. So in the real world, we're going to have very large datasets. So just think of it as an optimization. So here I can go from datasets, import, load dataset, and then here I go dataset equals load underscore dataset. So the type of the dataset, so it's a JSON file and the comma, and then my files, so data underscore files equals, so this is Hussein data.json. So here go Hussein underscore data.json. Let me zoom in, comma, and then we have a split. So here I go split equals train, and then let's run it. Okay, so now it's done. Let's create another code snippet and let's see what the dataset object looks like. So I run it, and here, as you can see, we have two fields, question and answer. This perfectly matches our dataset. So we have two fields in our JSON array, question and answer. Great. And here we also have 50 items. Let's see it further. I want to check out the first item within our dataset. So the 0th index. Great. So as you can see, our code works. Now, as our next step here, I want to install Unsloth dependencies onto my project. Or in other words, I want to set up Unsloth. So I'm going to be following the documentation here. So this is Unsloth's official documentation for Gemma 4. And let's scroll down. Here they have an installation step. Let me copy this. Let's create a text and do setting up Unsloth and a code snippet. And let's paste it like so. And one thing to keep in mind is while learning for this video, I found out that the transformers dependency has an error. And I found a GitHub issue where someone said that this problem is solved in an updated transformer version. So I'm going to change this from 5.5.0 to 5.5.2. And Unsloth doesn't work on the CPU, so I'm going to have to change to the GPU. So T for GPU. Save, and I think we're gonna have to run all of this again, but while it connects, let's create another code snippet, and this time I want to get my model. So here I go import Unsloth, sorry, not import Unsloth, it's from Unsloth, import fast model, and then I create my model name, so model underscore name, so the name of the model we're going to be using. And let's go back to the documentation, and scrolling down, they have all of these models. We're going to be choosing the smallest model here, which is Gemma 4 E2B. So the instructional model of 2 billion parameters. Let me copy this and paste it here. And then here we go model, comma, tokenizer equals fast model dot from pre-trained. So I take the pre-trained model, and then model underscore name equals, so it's model name, comma, the type none, comma, max sec length equals 1024, comma, and then load in 4-bit, not 4_bit, it's 4-bit equals true. So this means that we want to enable 4-bit quantization. This will reduce memory usage. Anyways, and then we have another parameter, full fine tuning equals false. So now it looks like I'm already connected to the GPU. So I'm going to run all of it now. So here I go, run all. Anyways, so while it runs here, I'm going to create another code snippet. And this time I want to prepare my model for fine tuning. So here I want to go model equals fast model dot get underscore PEFT underscore model. So the first parameter is going to be the model itself, comma, and then what we want to fine tune. So here we have fine tune underscore vision layers. I don't want to fine tune the vision layers, so set it to false, comma, and then fine tune underscore language layers, comma, equals, and we leave it on. So I want it to understand language. Then fine tune attention modules. This is for reasoning. So I want to enable this, true, and then fine tune MLP module equals true. That's it. And now we have the rest of the parameters. So we have R, which is, I believe, the rank. So by default, the Unsloth guys have set it to 8, but I'll set it to 16 because I want higher accuracy. However, keep in mind that it might lead to overfitting. Then we have LoRa underscore alpha, so the LoRa parameters, and we set it to 16. So the Unsloth guys suggest you to keep it equal. So alpha and the rank should be equal. And then we have the dropout, 0. Should it have a bias? No. So it's none, comma. And then we have a random state. So we set a random state to 3407. So while it runs, we run this one as well. And then while it runs, we create another code snippet. So now this time, let's talk about chat templates. If you don't know what they are, basically they're little frameworks or little messages that allow the model to interpret data properly. So for example, when it comes to Gemma 4, we have the following template. So for example, we have the system token, which indicates the system message. We have the user token, which indicates the user prompt. And we have the model token, which indicates the model's answer. So Unsloth already includes a function to convert our data into chat templates. And I'm going to show it to you now. So let's go from unsloth.chat templates, import get chat template. So this is the function to get the chat template. Oops, let me delete this. Anyways, here I go, tokenizer equals get chat template. And then the first parameter is going to be the tokenizer. And then the second parameter is going to be the large language model or the type of the large language model. So this time we're going to be using the Gemma 4 large language model. So let's run it. And then another code snippet. So now let's create a function to convert my training data into the chat templates. So here we can go def pre-process training data. And then the first parameter is going to be the example. Sorry, not the first parameter, our only parameter. Let's set it to item. So basically every item within my training data. And then instruction equals, so we get the question part. And then we get the response part. So response equals item answer. And before converting our data to chat templates, we have to follow a specific format that looks kind of like this. So we need to have an array of dictionaries, and the keys in those dictionaries should be a content field and a role field. So for example, we have a content and it's the user prompt. So we have the role user, and then we have the model's answer. So the assistant role, and then the following content. So let's go back and let's convert our data into that format. So here I go messages, sorry, not messages, it's actually message. And then here I go role, user, comma, content. So it's instruction. And then we have the role assistant. So the assistant or the model's answer. and then this response as the content. So let me autocomplete and let's remove this. And then here I go text equals tokenizer dot apply chat template. So I apply my chat template to this message. So here I go message comma tokenize equals false, and then add generation prompt, and that's false. And then we remove prefix. So dot remove prefix. So it's the BOS token. And then when that's done, we do return text as an object or as a dictionary. So let's run it. So no errors so far. Let's create another code snippet and apply this function to our training data set. So I create another variable training data set equals, and then here I go dataset dot map. So for every item within my data set, I apply this function. So pre-process training data, and then let's run it. Okay, so now that it has been run, let's create another code snippet and see how our data set looks like. So for example, let's see the first item within my data set. So the item with the 0th index. So here now, as you can see, we have 2 items within this dictionary. So the question and answer, just like before, just like earlier. And then we have a text field. So the text field is our user prompt and the model's answer converted into a chat template. So for example, we have the user token followed by the user prompt here. And then we have a model token followed by the model's answer. That means that our code works. However, we can even optimize this function. So for example, assume that your training data set has around 1 million items, and that would be very computationally expensive. So luckily we have an option called batched, and we can set it to true. And this means that our data set is going to be processed within batches. So instead of one item being sent at a time, we can send a list of items at the same time. So we're going to have to change our function as well. So this time our item is being sent in batches. So this is now a list of questions and this is now a list of answers. So now let's change our function accordingly. So here I create another new line here. Let's give myself some space and let's create another variable called texts. So this will hold all of our texts for all of our items. And then here I go for I in range len instructions. So for all of my instructions within my batch, I create a message for it. So message equals, actually, let me just remove this. This is a bit confusing. And as before, it's going to be an array and role of user, user like so. And then we have content, instructions with the index of I. So each item within my array, comma, role, model, so the model's answer, content, and just like this one, it's going to be responses. So in our responses, it's going to be response I. And then let's convert all of our items into our template, using our template, sorry. So I go tokenizer dot apply chat template. Here I go message, comma, tokenize. So just like before, false. I said the spelling wrong, it's false, comma, add generation prompt. So it should be false. And just like before, remove prefix, the BOS token. And at the end, I would append this to my text array. So text.append text. And then finally, I return my text array. So let's run this. And we don't have any errors. Let's run this one as well. Okay, so now we have an error. Instructions is not defined. So it's instruction. So let's run it again. And run this one again. Whoops, sorry, looks like I forgot to rename this variable as well. So it's instruction here as well. And furthermore, I also noticed that response has a wrong spelling. So let's run this and run it here. Okay, so now that, okay, so no errors so far. So let's run this one and hopefully we should get the same result. So as you can see, our code works and our text key has the correct value. That's great to see. Now in this part of the video, I would like to set up the training for my model. So let's scroll down, let's create a text snippet. And here I go training our model and let's create a code snippet. So here I go from TRL import sft trainer, comma, sft config. So now let's define our trainer. So sft trainer and then model. So I pass in my model and then we pass in our tokenizer as well. The tokenizer. And then I specify my data set. So train data set equals training data set. So this is the data set I want to pass. So it's training dataset, comma, and then eval dataset. So we don't have any dataset for evaluation. So I set it to none, comma, and then the arguments for my training. So arg equals sft config. So the text fields for my dataset. So dataset text field, and we have the text field. So it's text, comma, and then per device trained batch size. So the size of our batch, 1, gradient accumulation steps, let's say to 4, and then warm up steps, 5, and then max steps equals 60. So I'm going to train my model 60 times, and then learning rate equals 2e minus 4, and then logging steps equals 1, comma, and then optim, so our optimizer. So I'm going to choose ADMW underscore 8-bit, comma, weight underscore DK 0.001, and then LR scheduler type. So I want the linear optimizer, the linear scheduler, and then the seed value. So let's set the random seed to 3407, then report to none. Okay, so now that looks good. Let's run it. And hopefully we don't get any errors. So while it runs, let's create another code snippet. And here I go from unsloth.chat templates, import train on responses underscore only, and then trainer equals train underscore on responses only. So this function exists to improve training accuracy. So trainer, and then the second parameter is instruction part equals, so the token for the instruction part, that's turn user, so the user prompt, and then we have the response part, which is the model token. Let me remove this. This is not needed, and this looks good. Let's run it. Okay, so no errors so far. Let's create another code snippet, and finally let's train our model. So trainer stats equals trainer dot train. And now it's gonna take a while, so let's run it, and I'll meet you guys when it's done running. Okay guys, so I ran this cell twice, so I trained my model 2 times, and we now have a training loss that looks really low. So this seems really good. So now let's perform inference on this model. So here I go from unsloth.chat templates, import get chat template. So I go tokenizer equals get chat template tokenizer, comma, chat template equals Gemma, Gemma -4. So just like before, I'm just getting my chat template for my message. So message, and I get my prompt. So content, so this time it's an array type, text, comma, text, and then here I go, who is Hussein. And then I made an error here, so I'm gonna wrap it in curly braces like so. And here let's create another object, another key, sorry. So the role is user, and now let's give this input to my model. So inputs equals tokenizer dot apply chat template. So my message, comma, and this time add generation prompt will be true, and tokenize it will be false, and return tensors pt, tokenize will be true, and return dict will be true as well. And at the end I put this input to the GPU, so I go dot to CUDA. Now that I have my input object, let's pass it to the model. So I go output equal model dot generate, and I go input, comma, the maximum tokens it can get. So I do max new tokens, and let's do 1024, and then the temperature. So the temperature value recommended by the Gemma team is going to be 1.0, comma, we have another parameter top p 0.95, and then top k 64. And then let's pass in my output to my tokenizer. So tokenizer.batch decode outputs. That's it. Let's run it, and hopefully we get the correct answer. Okay, so we have an error, invalid syntax, and let's go up and see what's wrong. Oh yeah, so I forgot a comma here. Let's run it again. Another error. Looks like I messed it up. So let me fix it. So content. So let's remove this curly bracket here, and let's remove this curly bracket here. And I want to add my curly brackets here instead. and hopefully there are no errors this time. Whoops, another error, and let's see what the issue is. So it's a comma here. Let's run it again. Okay, now let's wait for the model's answer. Alright guys, so a while later we got the message, we got the model's answer, and here as you can see it says Hussein is a 23-year-old billionaire, which is perfectly correct. And then it says visionary founder and CEO of the company NovaStream. And let's scroll up to our data set and let's see if it's correct. Yes, it is correct. So Hussein is a 23-year-old billionaire and a visionary founder of NovaStream. That's great to see. This means that our model was completely correct. So let's scroll down and let's save the LoRa adapters of my model. So let's create a new code snippet. And here we go, model.save pre-trained. Let's save this model and let's call it Gemma_4 LoRa. And along with the model, I'm going to save the tokenizer as well. So tokenizer.save pre-trained Gemma for LoRa. And now let's run it. Okay, so now let's go back to the Explorer. And here, as you can see, my model adapters have now been saved. Alright guys, so now in my next part of this video, I want to convert my model into JGUF format. So basically this JGUF file format will allow me to run this model within Ollama. So to do so, first I would import the LoRa adapters. So here I go from Unsloth, import fast model, and then model comma tokenizer equals fast model.from pre-trained, and then model name, so it's Gemma for LoRa, and then max stack length, let's set it to 2048, and then load in 4-bit. So just like before, let's set it to true. So this seems fine for now. And then what I want to do is I want to save this model into float16 format. So to do so, I go model.save pre-trained, so Gemma_4-finetune. Sorry, it's not save pre-trained, it's save pre-trained merged, and then the second parameter is going to be tokenizer. And then when that's done, I want to run it. However, notice that I'm running out of system RAM, so I'm going to go to runtime, restart session. So I want to remove all of the variables from the session, and then when that's restarted, I just run it. So it's gonna take a while. It took me around 20 to 30 minutes when I was learning this concept. So when that's done, I'll meet you guys later. Okay guys, so a little update from me. I was running this code cell, however, I was running into RAM issues. I kept on running out of RAM or system memory. Therefore, I will stop this tutorial here. However, I have documented the steps I would have taken if I had not run out of memory. I would have exported my model to JGUF and then ran the model on Ollama. So that's it for today. In this video, you guys learned how to fine-tune the Gemma 4 large language model. If you guys have any questions, let me know within the comment section below. I'm very much open to opinions, ideas, and suggestions. Till then, see you later and bye-bye.